to the microprocessors. It's a more advanced when compared to microprocessors. And this entire system is called as a DSK, so which is called as DSP starter kit. It is having the DSP processor, external memory interfaces. This the two that you are showing is the external memory interfaces. These are the dip switches that is there. So these are for some hardware purposes. These are the main important two things that are there. So one is called as the adapter power supply. One is for the USB. This is for the USB. The white color switch is the USB supply. This is the adapter. So it is going the plus 5 volts power supply. So we are giving this power supply to the adapter and also to this particular USB. And this is the reset button. Only for the starting of the processor, you need to show this, press this particular reset once. That's all. And there are this DSP kit experiments are divided into two parts. Two non-real-time experiments and one real-time experiment are there. So two non-real-time experiments are, first one is linear and circular convolutions. Second program is endpoint DFT of the sequence. One real-time program we have is that is called as FIR filter, implementation of FIR filter. That is called as a real-time FIR program. So the difference between non-real-time and real-time programs is, using the non-real-time programs, you will be viewing the output on the monitor itself, but connecting the kit in both the cases is compulsory. But using the real-time programs, you will be connecting the output of the DSP kits and to the external device like CRO and function generator and viewing the output. So these are the main parts of this particular thing. There are four units, there are four ports here that are there. First one is called as the MIC in, microphone in, where you are giving the microphone input. Second one is called as the line in input. So from the function generator, you need to connect this particular to the line in input. Third one is called as a line out output. So from this line out output, you give to the CRO. And the last one, of course, is the headphone output. So the first and last are used for some speech processing applications, whereas now we are concerned with the second and 2 and 3. This is the MIC in input and the MIC, this is the line in input and the line out output. So from the function generator, you connect to line in, from the line out output, you connect to this CRO. We will come to this afterwards. So this is about the overview of this particular kit. So this is very advanced kit, DSP kit, so which is used for many applications, advanced applications. Okay, in your curriculum, you have in the second cycle of DSP kits, you have 3 programs, as I told you, 2 non-real-time programs and the 1 real-time program. So this is the heart of the DSP kit, which is called as the DSP processor. So it is responsible for processing all the signals, Now I will show you how to give the connections to this particular thing, DSP kit. So there are 2 connections that you have to make. One is called as adapter. So when you connect the adapter, automatically the lights are switched on and the DSP kit is started. And this is the USB cable that you are going to connect. So this is called as a USB cable that you are going to connect. So this USB, so whenever it is connected, actually the LEDs are going to blink here. You can see the user LEDs here. So beyond the dip switches, here is called as user LEDs. The user LEDs are going to glow for some time. So first, after connecting the kit, just press once the reset button. After that, you can start your process. Press once the reset button. Afterwards, you can start your process. Okay. So whenever you press the reset button, automatically the user LEDs will blink for some time and they stop for this. You can see that the user LEDs are blinking for some time and they can stop for the process. So now we will show you the monitor, how we can diagnose this particular thing, to make the DS6713 DSK diagnostics. Diagnostics are used for checking the connections of the DSP kits. So open this, double click and open this and start this particular connections, start this particular process. So when you start this particular process, it will show all the things: DSP, USB diagnostics, emulation diagnostics, USB diagnostics, emulation diagnostics, DSP diagnostics, external memory, flash diagnostics. So everything is your green light is coming, meaning that the connections are right and all the things. Okay, starting from the USB until the dip switch diagnostics, it is going to check all the hardware connections: USB, emulation, DSP. The DSP starts for DSP processor. External memory interface, any connections are there. Flash diagnostics, codec, flash ROMs and flash ROM diagnostics. Codecs, I told you 4 units for the codec configuration. Those diagnostics going to check. LED diagnostics, dip switch diagnostics. So I told you the hardware which switches are used. I told you that particular this one. So now it is just pass. It will display the message as pass. When it displays as the message as pass, now it means that you can go for making the connections. So when you display the pass, it will go for making the connections. Okay. So you can just now you can just close this particular DSP kits, and then you can start your using your DSP. So for using this particular CC Studio, the name of the software that you are going to use is called as CC Studio, which is abbreviated as Code Composer Studio. So Code Composer Studio is a supporting software for running your program, both non-real time as well as real time programs. So just go for this particular Code Composer Studio, open this Code Composer. So whenever you open this particular Code Composer Studio, automatically a window will come here. Just maximize that particular window. So first of all, the first and foremost thing that you have to do is go for debug and connect. First of all, you have to connect your debug this one. So go for debug and connect. So whenever you click debug and connect, it will show target is now connected. So a disassembly will open. So already you have done a previous program that will open. Just close that, which is not required for you. Just close that particular connection. Okay. So next, after this particular thing, go for, now I am explaining the real time, this non-real time procedure. So go for creation of new project. So go for project new. So create a project named, okay, create a project named new one something. So type this particular thing and create a project named new one. So when you create a project named new one, automatically a project named this new one will be created. So whenever you create a new project named new one, automatically a project named new one will be created, and you will have this particular this one. So the target must be TMS 67XX. The target must be TMS 67XX. Just finish that particular target. So whenever you click that finish that particular target, automatically a project named new one will be created. You can see that particular this one for the new one. Okay, automatically a project name new one will be created, and here the reference folder for your project is this new one.pjs is a reference folder for your project. Okay, so next procedure is, after creation of new project, go for file new source file. Okay, so for that, so here in this you need to type the source code for this. You need to type the source code. So hash include std. So I am typing a small test program, and I am showing the testing the output here. Then afterwards we will proceed for the exact program. First of all, let us go for this for the sake of demo purpose, I am giving you this particular this one. So I pressed like a small message like hello. Okay, I pressed a small message like hello. So hash include std.h main printf hello. Okay, right. So a message hello will be displayed after this one. So you have created a new project, and then this source file is there. So go for saving the source file. File save as. For saving the source file, you have to go for file save as. What is that? I told you the reference folder for this particular change is CC Studio My Projects. Now you have created a new one as your folder. Automatically a folder will be created. So in this you have to save your particular project name, this one. So it has a1.c something. Okay, so a1.c something, just type it as a1.c, and then you save this particular this one in your system. Okay, so a1.c will be your it is the source code for this. Okay, right. Now what you have to do is you need to add this particular this source file to the project. For adding this, go for right click and then add files to project, or you can go for project add files to project. You can do anything. So go for it, it's either directly you can go for project add files to project. Go for selecting the source file and then add this particular source file here. So we added this source file a1.c added to this particular source file to this. So after adding this source file, there are three files that are to be added. One is a source file, second one is a library file, and third one is a linker command file. These three are the files that need to be added. So once again go for add files to project. So go for, I am showing the path for showing the library file. So C drive, go for C drive, CC Studio, C drive studio is the reference for folder for everything, CC Studio. So C6000, CT tools, LIB. In this LIB folder, you need to go for object and library files. In this LIB folder, you need to go for object and library files. So go for object and library files. So this is object and library files. So select this rts6700.lib and add this particular rts6700.lib. So you get this particular rts67. Whenever this rts6700.lib is added, okay, there are two files that are added. One is a source file and rts6700.lib. Next thing is once again go for add files to project. Go for adding the linker command file. The source for path for adding the linker command file is CC Studio tutorials DSK6713. In this a folder named hello1 will be there. So hello1, in this you go for selecting linker command files. Go for selecting linker command files and select this hello.cmd. So hello.cmd will be this one for your linker command file for your project. Okay. So first of all you have a1.c, then this one this hello. So there are three files that you have added. One is a source file a1.c, the library file rts6100.lib, and hello.cmd is the linker command file that you have added. Okay. So after addition of all these particular three files, the next task is you have to go for compiling, building and rebuilding your project. Compile, build and rebuild your project. So for these things what you have to do, go for compile option. So compile first. So it has been compiled. So whenever it's compiled, it will show compile complete, 0 errors, 1 warning. So warning is no problem is there, warning. So just for building. Building is you are going to convert your source code into assembly language code. That is for the building purpose. So next is rebuild. Rebuild your this one. So after compiling, building and rebuilding the source file, next go for loading your program in the this DSP kit. So go for that, go for file load program, debug new one.o. So file load program is new one.o. So this is loaded now. So without wasting much time, go for run option here. So click run option, or you can go for debug run option. Anything can be there. So you can click run option or you can connect this one. Okay. So just click run option. So whenever you click run option, automatically the message will be displayed here. The output has come here named as hello. This is the message that is come. Okay. So this is the demo of working this particular project, non-real-time project. We have two programs. One is linear and circular convolution, and the second program is endpoint DSP, that is a non-real-time experiment. And of course the real-time program is you have the DSP kit. Using the DSP kit you have the this DSP processor using the FIR filter. Implementation of FIR filter will be your this one. Okay. So separate procedure is there for the this is the procedure for non-real-time programs. Separate procedure will be there for real-time programs also. Okay. So like this you need to do this. After this one you close your project. After doing that you go for closing your project. Do you want to wish to save this one before closing the project, like that is last. So this is yes, click yes such that it will be closed. Okay. So after that you can close your this one. You can close your this one.